So this is example 2 for topic 1, lesson 2. In example 2, the main focus is to make sure you understand what's a perfect square and what's not a perfect square, and what in the world would a perfect square be. So let's take a look at this. There's not a lot of work to do in this. You just have to know how you're classified as a perfect square, and I'll explain this to you a little bit to make it nice and easy for you. So it says classify the square root of 3. The square root of 3 means the non-negative square root of 3. Non-negative just means that it's positive. The square root of a number is a number that when multiplied by itself equals the original number. The radical symbol, square root, is used to denote the non-negative square root. So anytime you see this symbol, the square root symbol, that means it's non-negative. It will always be positive. That's just something very simple and one of the math things that we already know. When we see numbers that don't have negative signs, they're not negative. So click on each square to reveal the information about the square root. So if I click on this, you'll notice that it says 1 times 1 equals 1. The square root of 1 is 1. And if I click on this one, you can see that the square root of that 2 times 2 is 4, and the square root of 4 is 2. And then I do this one, and it's the same thing. 3 times 3 is 9. Square root of 9 is equal to 3. So I didn't explain these a whole lot right now, guys, because it tells me quickly to just jump on to page 2. So if I click this one, I click this one, I click this one, I read it, and then I jump to page 2. And page 2 now has for you an explanation. So let me explain this to you as you're looking at it. This is one block. Okay, one block can make a perfect square. So if you look at the side lengths for this square, this side is equal to 1 unit, and this side is equal to 1 unit. I say unit because they don't tell us if it's inches or feet or yards or miles. For whatever it is, it is. So if we don't have a label, we call it a unit. So this is side 1 and 1. Notice this one is created by 4 blocks, and the side lengths are 2 and 2. And the reason for that is 2 times 2 is equal to 4. So the number 4 is a perfect square because 4 blocks can create a perfect square. We are able to do that. When we go up to this next one, we have 3, 3. So we have a side length of 3 and a side length of 3. And notice there are 9 blocks. So if we have a certain number of blocks that can create a perfect square, we call them a perfect square. And I'm fairly certain that if you guys knew that the side lengths were 4, 4 times 4 gives us 16. So 16 is another perfect square because it is a number that we can take 16 blocks and we can create a perfect square with them. Okay, so your perfect square and your square roots go hand in hand. If you have the area, which is equal to 1, and you do the square root of 1, it will tell you the side lengths. So this square root is basically your area, and this is your side length. So if you have a square that has an area of 4, which means there's 4 total blocks, and you do the square root of 4, that will be equal to 2. If you have total blocks of 9, the square root of 9 is equal to 3, and those 3 indicate your side lengths. Now, I'll also show you this on example 2 just because I want you to get used to this a little bit. Over here, you have some tools. So if you go to Math Tools, and that will bring up this screen. And on Math Tools, we will use a lot of these math tools throughout the school year, but if you click on Calculator, you'll notice that on the calculator, you have that radical symbol right here. So if I use that radical symbol, and let's just say, for example, I want the square root of 16, and obviously the square root of 16 is equal to 4 because 4 times 4 is 16. But let's say I do something that is not a perfect square. Let's say I do the square root of 17. Well, let me clear it all first. Square root of 17 is equal to this. Now, do you see how it's not a perfect number like the number 4? That means that this number will go on and on and on and on forever. Now, our indicator said that we got to have ... but on a calculator, it's not going to put ... So anytime you put a square root in there, or eventually we'll be working with cube roots, when you put those onto your calculator and you see that it's not perfect, that means that it is one of the irrational numbers, even though your calculator cannot put a ... there. So be very careful of that. So when we take a look at this, that is all they want you to know about perfect squares. So some numbers are perfect squares, and they are called rational because the square root of 9 is 3. So it's rational because it's a number 3, and we can write 3 as a fraction. Some, like we just did, is the square root of 17, are irrational because they go on and on forever. So one of the major irrational numbers is any perfect square, any number that is not a perfect square. So if we do the square root of 17, if we do the square root of 19, if we do the square root of 20, those are not perfect squares, which means they are irrational. So keep that in mind. There's many irrational numbers. Most of them are just square roots that aren't perfect squares. And pi will always be irrational.